Hello, and thank you for watching our video on digital electronics, the Tic Tac Toe game. Today, my partner and I will be showing you how to make a Tic Tac Toe game using an FPGA, which is programmable using Verilog. And now, the moment you've all been waiting for. Who is my lab partner? His name is Matt. No, not that Matt. That's the wrong Matt. His name is Matt. See, I'm gonna have to be more specific here. Alright, his name is Matt Schmidt, and you'll be hearing from him a little bit later. But now I'm going to take you through Verilog and explain what it does. Alright, so here is our Verilog file, and it may look a little bit confusing. It is computer code, so if you haven't seen that, it can be hard to understand. But basically what you need to know is there's three main things that happen. One is we input the position of our switches on our FPGA, which will determine what the board looks like for our tic-tac-toe board. That's the first thing. We send that into a program that we have called winner here on the left, and then that determines the status of the game. If player 1 has won, if player 2 has won, or if player 3 has won. So let's take a look at how that works here with a diagram. Alright, so here we have the example on the left of what it looks like. So a tic-tac-toe board is 3 by 3, obviously. But what we have to do with our FPGA is we have to have two boards. The first one is 0 through 8, the next one is 9 through 17. And basically what we do is that we say for the status of the game, if player 0, which would be player 1, we just have it labeled player 0, when player 0 enters a X or an O on one spot, say they enter it on this spot here, then we put a true statement in our program on 1 and on 10 so that it knows it's player 0. Now if it's player 1 that enters it here, we only put a true on spot 1 so we can differentiate between player 0 and player 1. Basically then we say if for player 1 they have to have a combination of 3 in a row horizontally, vertically, or diagonally. So what we say is on this board down here, if player 1 has spots here, here, and here, then they've won the game. If player 0 had spots here, here, and here, they've won the game, or any other combination. If not, we say the game continues as normal. If all the spaces are filled but no one has 3 in a row, we say it's a cat's game. Now back to Verilog. What we do for the second part is we take this status and we put it back into our main program here. Now we say if status is normal play, what we want to do is we want to have our 7-segment displays on the FPGA represent what would be normal play. So it would show on 3 of these 7-segment displays, it's going to show the board, it's going to show what player 1 has, what player 2 has, and then on the last one it shows whose turn it is, whether it's a 1 or a 2. So what we have to do is, depending on whether it's normal play, player 1 wins, player 2 wins, or cat wins, we have to display the appropriate thing on the 7-segment display. If player 1 wins, we'll flash 1s on the display so that you know 1 wins. If 2 wins, we flash 2s, and if the cat wins, we flash cat. And we spell it with the 7-segment displays. So let's take a look at the diagram and see how we put those displays up. Alright, so here we have the 7-segment displays pictured on the right. So basically what we do is, in Verilog, it's a 64-bit number that we put here, and if one of the bits in that number is true, then that particular segment, say 58, if 58 is true, then this segment will light up on the LED display. Now there's only 4 7-segment displays, so why do we have 8 pictured here? The idea is that if we want something to flash, we take this 64-bit number, we write it to one of them and not to the other. And so then if 30 and 29 were lit up, but 62 and 61 were not, then it would flash a 1 in that particular 7-segment display. So that's basically how we accomplish it. We say whatever we want to write. We can make a C for cat, we can make a 1, we can make a 2, we can even make an exclamation point using the decimal points. So we write any combination in that 64-bit number corresponding to the status of the game, and if it's normal play, then what these display, or at least what these three on the left display, is the board status. So the 9 horizontal segments in these 3 7-segment displays represent where the players have played, so they'll represent what the board looks like. Alright, so then the last thing is just how we get the status to be reflected by the 7-segment display with 64-bit numbers. So here, if it's normal play, then the 9 horizontal segments in the 7-segment displays that we want to represent the board are here: board 9, board 12, board 15, board 11, board 14, board 17, board 10, board 13, and board 16. And that's only half of it, because if it's player 1, it'll be flashing. If it's player 2, it'll be solid. So we also have down here board 0, 3, 6, 2, 5, 8, and 1, 4, 7. So with that, we've covered how we can show which player it is that has a specific spot on the board. Say it's the upper left, then board 0 and board 9 will determine whether it's player 1 or player 2, because if board 0 is on but 9 is not, then we know that it's player 1 who has it, because they are the one who's on only the bottom board. So that's basically how we do that. With the other ones, it's fairly simple. We've just put in 64-bit numbers here. They're all zeros on the bottom half here. Some of them are 1s, just so that we can flash a 1. Same thing with flashing a 2, same thing with flashing a cat. And so we have a program here called Total Control that was written by Dr. Ronk, and basically makes sure that we can have control over what the segments are displaying by putting that status, taking that status and putting those 64-bit numbers into Total Control. And that's about it. So Matt's going to show us here how the game works. We're going to see it in action, and enjoy.
Now that we have the board programmed, we're actually going to play the game. You can see we have this on the 7-segment display which player is up, so we'll have 1 right now, or player 2. And then this is the board itself, so we'll have columns and rows. And columns are these 3 switches here, so 1, 2, 3, and rows are these ones, 1, 2, 3. So for example, we pick column 1, row 1, shows player 1 as a solid. We go to column 1, row 2. It'll show player's 2's choice as a flashing, and then it goes back to player 1's turn. As we play through the game, we're going to end up with 3 victory conditions. Player 1 wins, it'll flash all 1s. Player 2 wins, it'll flash all 2s, or cat's game. Okay, and we can see here that player 1 is about to win, and when they do, all the 1s flash, player 1 wins. Alright, and now we can see here that player 2 is about to win. He does, all 2s show up, and player 2 wins. Okay, now we can see here that there's only 1 spot left on the board, and when player 1 goes, it ends up being a cat game. Nobody